Hi, and welcome to the Electric Revolution Skills Hub podcast. My name is Dean, and today I've got the fantastic opportunity of interviewing Venn Chesterton, who is the Deputy Director of Driving the Electric Revolution. The challenge is investing £80 million in electrification technologies, including power, electronics, motors and drives, which is the PEMD. And the investment will support the UK's push towards a net zero carbon economy and contribute to the development of clean technology supply chains worth £80 billion in gross domestic product by 2050. Hi, Venn. How are you?
Hi there. I'm well, thanks, Dean. How are you?
Yeah, I'm good. Thank you. Good. Thank you very much for joining me. I gave you a short introduction about you and your kind of role. Would you like to expand even further, certainly about your role and the driving the electric revolution part of it?
Absolutely. Yeah. So I'm Deputy Director for Driving the Electric Revolution, and that is a government-backed challenge, which is designed and it has been delivering on growing the UK supply chain for power electronics, motors and drives. Now, power electronics, motors and drives are the underpinning technologies for electrification.
So what was the initial concept? You talked about government backed, so I'm assuming there's a government grant in there. What about the initial concept and objectives of the DER?
Yeah, so driving the electric revolution was industry-led. In a nutshell, the government said to industry across the board, look, we want to support the growth of the UK economy. What can we do to best support you? And there were applications or explanations of what could be helpful from all different areas of industry. So this one came from the power electronics, motors and drive community, but there were ones from healthy living. There were ones from other technologies around net zero, so construction or plastics or things like that. So across the board, there are various different ideas that came forward, and this one specifically was came from the existing UK power electronics, motors and drives community, and those companies that know and could see that they were going to start needing to use that supply chain, those components. So you can think of, say, existing automotive companies that are aware that they're going to start to make electric vehicles and will need the supply chain, or the aerospace industry, similar story there. So those different various areas of industry came together and said to the government, if you can provide us with a sum of money, and in this case it was £80 million, and provide it to us in a sensible, measured way, we can grow and we can respond. And what they said in the business plan was £154 million back to the economy. We're a couple of years into the challenge now, and we're already nearly there. So we're going to absolutely smash that initial sort of estimation from industry in terms of what it'll do to the economy.
Is already part of industry that are developing these in the electrification, I don't know if it's a sector or the drive. Do they realise that they're part of a bigger entity? For example, PEMD you mentioned, do they understand that exists? Do they understand that what are we doing to get this message out to people that there is the government funding here? There are facilities that these businesses can use and businesses that want to transition into electrification. How well known is it in the industry, and is that a challenge for us?
So, I mean, in the early days, the bits of the industry were well known. They'd come forward, and we spent a lot of time on the road, spending a lot of time in hotels and whatnot. And we went and visited the UK ecosystem, and we've done various different events to bring them together, to get them talking. And very much now, we feel like we know a good enough chunk of the industry. We never say all of it, but we know a lot of the UK power electronics industry and motors and drives industry. There's so many different ways of cutting it as well. So you've got the end user. So you've got, as I said earlier, the aerospace or the car companies or the wind turbine sort of motor manufacturers. We've got those types of bits of the industry. And then you've got all the way down to the people who are manufacturing the magnetic materials that go into the motors, or the people that are making the wafers that end up going into the power electronics, and everything in between from that point of view.
So essentially, that's the whole supply chain, isn't it? And it's part of it where we can help identify gaps in the supply chains and help industry to fill them with some collaborative effort in some way.
Yeah, absolutely. So there's three ways in which we're sort of responding to industry's ask. And one of those ways is about collaborative research and development. And specifically, we've been targeting that to try and use the R&D activities to grow the network and the supply chain. So we ask for, within those collaborations and those research and development projects, we ask for different levels of the supply chain to be part of it. So we'd have potentially an OEM and someone that's feeding into the OEM, the one level down that the OEM are buying from, and maybe a third partner who are also further down the supply chain, and making sure that that sort of integration is happening during the R&D process, so that the UK is where a lot of these things are happening, and they're not, it's all well and good. You've got a car company at the top, but if they're bringing all the components from other parts of the world, then you're not growing that UK base, that UK supply chain. So yeah, the R&D and the R&D is really the funding. So about almost £40 million we spent on research and development. And it's such an impressive vehicle when you look at the returns you get and look at the impact that has on the UK ecosystem and the UK economy, because the way they tend to work, and they're all different shapes and sizes, but essentially you'll have a company or a number of companies saying, look, we know how to make this, we know how to manufacture this widget, this whatever it is, new type of motor. What we're not sure about is how to manufacture them at scale, to produce the right numbers at the right quality point, at the right cost point, so that our customers, whoever that might be, an OEM, a car company or an aerospace company or a rail company or whoever it might be, wants to buy it from us. So can you support us in learning and doing some research and development in that manufacturing process? So a good example of a project, you'd have that kind of company looking at, we want to manufacture something, and then you might have one or two or three or four of the end users, the customers, ultimate customers, that are either active participants, and so they're maybe doing a bit of the project where they might take one of them and test it and check it does work, or they might help with some of the designing of the product or whatever. And then you might have an academic institution that would be providing support and guidance that, from that area. The academic base in the UK is phenomenal, so it's a good area to look. And then together they'll do maybe 2 or between 1 and 3 year project, where at the end of it, the ideal outcome at the end of it is that that company is now part of the supply chain of one or more of those larger OEMs, and it's UK success story. So that's the kind of thing that we have been doing over the last few years with our R&D.
And is that available for all businesses? How do they do they have to apply to you, or can they just jump on the
so in Innovate UK, we spend more than £1 billion a year on that type, many different ways of providing that type of support. And I mean, this is across the board. So there's £40 million that has been spent through this challenge on PEMD, but there's things being spent on health and life sciences and manufacturing and various different areas. So Innovate UK is well versed in doing this, and that support is available. And there are more general pots to go into, so any good idea can go into it, called SMART, but our ones are very much targeted at that UK PEMD supply chain.
So what about you and your journey then? How did you get into all of this?
Yeah, I left university longer ago than I'd like to remember, but quite a while
Not
ago.
as long as me.
And wanted to do something around climate change and sustainability, and I had no idea what. And I remember speaking to Mike Berry, who did Marks and Spencer's Plan A, and he said to me something along the lines of, you need to get good at something, you need to get a skill, and then put climate change onto that. You can't just, say I want to do something climate change, you've got to get good at something. So I went and joined the Transport for London graduate scheme on the basis that transport makes up a good portion of climate change related emissions. It's roughly a quarter, and so I thought, well, that's a good place to start. And I worked on various different things, active travel, cycling, walking, that type of thing. But the thing that really grabbed me was electrification of what TfL were doing. So that was hybrid bus program, the electric vehicle delivery plan in its early days, 2008-9, developing that. And then after a few years of doing those types of things at TfL, I went and did some consulting work. I became a consultant. So this was similar types of things, but on a more sort of European scale rather than just London. But what I kept on coming up against was actually the demand was there. People wanted, whether it be electric buses or whether it be other things, electrification of heat or looking at getting rid of gas powered energy sources, that type of stuff. And the problem was, the gap was actually the supply chain and the lack of the manufacturing capability for these things that people were very happy to bring into their lives. So that's where the job at Innovate UK came in. And there to build that UK certainly capability in manufacturing all of these components. And I was fortunate enough to be involved, in what is now driving the electric revolution, and working with industry to say, look, how can we increase the speed of change? How can we support you in growing the bits of industry that exist? How can we grow you faster than would otherwise happen without government support? And that's where we've come to with driving electric revolution. It's all about the demand is there. If you want to buy an electric car today, you're going to wait for a year or so. The demand isn't the problem; it's the supply. It's the supply of those components, and that's what driving electric revolution is there to deal with. And actually, it's given me a real insight into more broadly the supply chain issues, and actually, I think that's one of the things that will underpin the sort of the move towards net zero and dealing with climate change is the solutions exist today for many of these things. Almost we can probably deal with climate change roughly about with the knowledge we have now. It's about scaling all of that as rapidly as we can. And that's what really gets me excited with my current job.
Dare I say, is it your dream job? It sounds like it.
Yeah, I really enjoy it. I think that something I want to get more involved in is more broad sort of supply chain growth and development, because I think there's still a lot of low hanging fruit there to improve companies' performance with climate change and other CSR related issues.
A lot of this is what I'm going to ask you next is kind of opinion based, really. Maybe some statistics in there from your research, but what in your opinion are we good at in the UK within these sectors? And what do you think we need work on? What areas do you think we need work on or support with?
So the UK is so globally world leading in research, and our academic base is phenomenal. And it's not just me saying this. This is a well-known global understanding. The UK is a very strong place to go to do your research and your industrial research on power electronics, motors and drives. And if you look at the places in which around the UK that have got these this world-leading excellence, we have supported and funded a lot of those academic institutions, alongside the industrial UK-based in organisations, so that trying to bring that research out into sort of commercial and industrialisation and commercialisation of the research. I think another area that we're incredibly strong at in the UK is the lower volume, higher cost. So, the idea that we might set up a manufacturing plant in the UK that is rolling off, thousands of motors at a very cheap cost point, low quality. It may happen, but I that's not where our strength is necessarily going to lie. It's far more likely to be incredibly high quality, high end, precision engineered type of motors that are going to end up in your electric vertical takeoff and landing kind of aeroplanes, or will end up in your high end. You're looking at McLaren or Jaguar Land Rover, those type of brands in the auto sector. We're going to see those. So these are things that actually the weight saving of using a slightly more novel material is worth it, because you're looking at weight's important, or the increased time between something getting very hot and then cooling back down again so it can be used again is very important, because it's about racing or whatever. So it's where you're gonna that's where we already do excel. And I think when we're looking at the places where P and D will do well in the UK, it's those types of applications where it's incredibly highly engineered, incredible engineering, and high cost, and potentially a lot more jobs in that type of thing. If you've got an automated plant that's churning out millions of motors, there might not actually be that many jobs associated with that. Whereas when you've got some of this more high-end precision engineering, then there are a lot more highly skilled jobs around that, and the economy potentially benefits more from that type of manufacturing, certainly from a UK context.
You just mentioned jobs there, and with any growing sector, certainly at the rate that electrification seems to be growing, there's generally, like engineering years ago, there's generally like a skills gap, isn't there, of several years or decades sometimes, where we've not got enough people to fulfill those jobs than we've done the acceleration in the curve. How is that? Is part of the funding for that?
Yeah, absolutely. It's a real concern that we have had, and industry had years ago when they were pulling this together, when we were putting this together with industry. And the way that we're solving that is a few different things we're doing. But as you said, a lot of it takes time. And so we've got just over £4 million that we put into quite large programs of reskilling, retraining, upskilling of the workforce. So this is all the way from taking outreach work we're doing into primary schools, through secondary schools, into further education colleges, which are incredibly important. So understanding the basics of how to manufacture, how to work with these components. When you're talking about, if you electrocute yourself here, it's a real serious problem. It's that type of hands-on training is important, and then all the way through then to the sort of the academics. So the doing masters, engineering courses, all the way through to sort of PhD level training, and then within that we've got a huge amount of work on taking the existing very skilled workforce in an engineering field that maybe there's not going to be as many jobs for in the future. For example, if you currently make catalytic converters, you currently make the after treatment systems for internal combustion engine vehicles, clean the exhaust slightly. That job may not exist in a few decades' time, but it's incredibly highly skilled. You're working with heat, you're working with chemicals, you're working with things that we need in the power electronics, motors and drives industry. So a bit of retraining for that type of person makes them a very skilled employee for someone that's doing PEMD. And equally, you've got companies that are, I guess, pivoting slightly towards this or growing, and other bits might not be. So again, it's about the retraining and the reskilling. So it's taking an engineer that's got 20 years experience, doing a week, 2-week boot camp, or over a year, taking them out of work 1 day a week for a few months, and teaching them some of these extra skills they might need. So yeah, that's the program we've got is deep and wide around trying to upskill, reskill, get the UK workforce ready for this electrification.
So in this country, we're fairly well known for having lots of mechanical engineers. Are you saying that we can actually retrain mechanical engineers, as just one example, and create almost hybrids within the mechanical and electrical sense?
I mean, that's the sweet spot, right? So certainly a motor is both of those things. So designing those types of and manufacturing those types of things, you need both. So yes, absolutely. And it's not necessarily it's not necessarily a difficult thing to do. I mean, it is in many ways, but actually the retraining, the taking the skilled people and getting them ready for these new skills is something that can be done, and we are doing. So we've got some world-leading academic institutions that are going to industry and saying, what is it you need retraining with, reskilling with? And this is what we've funded. And then industry saying this, and this. And then they're putting together modules in a way that is accessible to industry so that type of stuff can happen. And then at the lower ends, there's some things that some people and studies and whatnot that would say that unless you get a primary school child playing with things, changing a fuse or whatever it might be, you lose them. If they haven't done that type of thing and held a screwdriver when they go to secondary school, then they're probably never necessarily going to be an engineer of any type. So some of our outreach work is aimed all the way down there, thinking, in 10, 15 years' time, these are going to be the engineers that we'll need. And equally, when thinking about secondary school, when people are reaching that kind of key point when they're thinking about leaving secondary school, what is it they're going to do? What is it that the world is their oyster? And trying to make sure that they understand that a career in STEM more generally, but certainly power electronics, motors and drives is an interesting place to go. There's a lot of problems to solve. There's a lot of interesting things to be done. And if you're interested in climate change, if you're interested in the environment, becoming a PEMD engineer or working on the manufacturing of PEMD components is a really worthwhile practical thing to do to deal with the climate crisis.
Life-changing for the individual, plus life-changing for hopefully the planet in the future.
Absolutely.
How you mentioned schools there. I mean, you touched on primary schools. What do you do with the primary school children in terms of PEMD? Is it not just too advanced for them, or fun?
No, it's really fun what we do with them. So we've got a box, a STEM box that we take in. I mean, a lot of it's about teaching teachers. So a lot of teachers can be nervous about teaching STEM. So the box is sort of, you open it up and it's got really clear instructions for the teacher on how to run. It's about 2 days worth of teaching. They either do it in 2 days or they do it over, say, a month or two, a couple of hours a week. And essentially, there's lots of different bits. They have magnets. They can wander around and pick things up, what's magnetic, what's not. But they get to make a motor as a team. So 6 kids in a team, and they'll literally wind a bobbin with wire, and then they'll pop those bobbins into something that's been made from a sort of cardboard cutout of a motor. And then they'll get to turn each one of those bobbins on. So they're making an electromagnet. And then in the middle, there'll be there's a little pin that spins. So if they turn them on in order, so each child takes a turn of turning the electromagnet they've made on, they'll make that spin, and that's a motor. And then each team, so they'll form a team, will race other teams in the same class, and there can be a winner for the quickest round or the most revolutions or whatever it might be. And yeah, we've done it a few times, and it's a lot of fun. Some of the kids get really enthused, and at the end of it, you can say, well, look, if you're interested in this, there's more you can do. This is the life you can lead doing this type of thing.
That's fabulous. Do the winners get no homework for the week? That's the intensive, isn't it? So there's obviously an industrial factor and a commercial factor to this electrification drive, but the end goal is also the climate, isn't it? We are really struggling with the planet warming generally year on year, very strange seasons that we're having. And just the weather's just generally more volatile, and there tends to be quite a few more natural disasters than there used to be. I spoke with a polar explorer, Alex Hibbert, on a podcast, and he spoke about his last 10 years visiting Greenland and how he's basically seen the ice cap melting year on year when he goes. And 10 years ago, he was visiting places that are just kind of sea ice now floating around. How important is all of our effort, including the effort that you guys are doing? How important is it to climate change? And do you think it will make much impact at all?
Yeah, I mean, that's the underpinning reason why I do what I do is climate change. That's the thing that drives me. That's the thing that gets me out of bed in the morning. And as you said, the climate is changing. It has changed, and it's going to continue to do so. The thing that keeps me going is that every single gram of CO2 equivalent that we cannot put into the atmosphere means that climate change will be slightly less bad. You know, it's going to have disastrous consequences as it stands today. For every gram of CO2 that we don't put in, it's going to be slightly less disastrous. And what we're doing at Driving the Electric Revolution, the way that it feeds into that is that it is speeding up and increasing the adoption of those technologies that are zero emission or a lot less emissions than would otherwise happen. So the speed at which you can get those products into people's hands so that they are using a electric car rather than a conventional car. So the more of that we can do. And I use electric vehicles as an example. I have done because it's the most relatable and it's the most close to market. But the work we're doing in this space in power electronics, motors and drives is across the board. It underpins everything electrical and everything electrical that moves, certainly. So this is all the way from a wind turbine that is producing the electricity, that is a motor, and all the way through to the conditioning of that power so that it can turn your light on in your house. And then if you're thinking about rail or marine or automotive or aerospace or industrial, off-highway, all of these different types of components that need to be electrified and need to be replacing the internal combustion engine, or need to be replacing massive gas turbines or whatever it might be. The components, the faster we can get them into people's hands that are using them, the less emissions we'll have. And that's what drives me. That's why I enjoy doing what I do at Driving the Electric Revolution.
Obviously, it's a world problem. It's not just the UK, and we are an important but relatively small island in this world. Do you see us as one of the, not pioneers generally, but the market leaders in this drive for supporting electrification and net zero, and kind of eliminating fossil fuels? Who are the good countries that are doing it?
I think there's a lot of impressive things that the UK is doing, and we may not be putting the money in that you might be seeing from, say, the EU or North America, and I mean China is leading the world with a lot of these things. But I think what we are doing is incredibly well targeted, focused programs that are growing the bits of the UK economy that are most likely to grow effectively. And are world leading as it stands. So we're growing, we're building on what we've got already. But yeah, there's other bits of the globe that are obviously doing incredible things as well as the UK, and it will require that everyone needs to play their parts. And one of the other things I think we're doing as well is some really interesting work on sort of reusing and recycling components. So as it stands now, a wind turbine will have thousands of times more rare earth magnets in it than a vehicle motor. So if you can do something to remove the rare earth magnets from a wind turbine, the impact that has is vast in terms of resource efficiency and the impact of mining on the environment, for example. So some of our projects are looking at exactly that. So looking at either removing the rare earth entirely. So one of our projects is looking at redesigning how a wind turbine works and looks so that it doesn't require the rare earth. You use the rare earth to make smaller magnet. You can have it maybe half the size for the same output by using rare earth over using none. But if you redesign it, that's maybe not that big an issue. So that's one of the projects we're looking at. For example, another one is looking at taking magnets that already have been used and reformatting those so they can be reused back into the supply chain as good as virgin material. So this is the type of thing, as these things become more prolific around the country, there's going to be more opportunities to recycle as well. So the work we're doing that is truly global leading in that space is going to become more and more important as we go forward in electrification.
I know that you touched on a few of these areas already, but can you talk to me about the 3 pillars and what they are and probably where the grant's been spent?
Yeah, absolutely. So the 3 pillars, this is a bit of an odd phrase, but for us, it's industry said this, we need support, and this is the type of way that we can. So we worked with industry a lot, working up how this should be delivered, because obviously there's rules around how you can provide government funding and aid to industry. And then there's what industry want, and they're very different things. And so the 3 main ways in which we're supporting industry, one of them is through collaborative research and development. And so this is where you have, it comes in different flavors, but we've funded over 160 different companies, about more than 50 projects within those. So each project's got a number of different partners. We've got a whole nother tranche and we've just signed off on them a couple of days ago. I can't announce them yet, but that's another, more than a dozen projects. So
these are the commercial projects, right? Commercial projects.
These are commercial projects. So the idea of these projects is you would have a company that's normally currently working in the PEMD space. So they might be making a component that goes into a motor. They might be making a component that goes into power electronics, or they're making the whole thing of power electronics, motors and drives all together as a unit, and all different flavors of what they're making, and at scale as well. So there might be one that's making something the size of this room that goes into a wind turbine. There might be one that's making something that's tiny, going into the movement of a small electric moped or something, and it's everything in between. And normally the way this will work is you'll have an academic partner that's providing some of the support on the know-how on how to do what it is they might want to do. You've got the industrial partner, and there might be a number of those in different areas of the supply chain. And they're essentially going from, I know how to make this at the moment. I've got my production line. I need to make this a bit better, a bit faster, a bit more efficiently. And I've got a bit of research and development I can do, means that I've got 8 steps in my process of how I make my thing. I'm going to take 3 of them out, and I'm going to redo that and make that a better process, put that back in, and that's going to reduce my costs, or it's going to increase the quality, or mean that I can make them 5 times faster, or whatever it is. And then you've got a sort of normally an end user, someone that might want to buy that product would be a partner, and maybe someone in their supply chain. So it may be the person that's component is attached to their product at that point, might be a project partner. And the thing that's really great about it is you get the collaboration. So you get the collaboration between the different organizations working together with our funding. And for a larger company, it's about 50% is government funding. For a smaller company, it's maybe 70% would come from the government. And for a university, it's 100% funded through us. So that's one area of what we've done. We've got some fantastic success story. You've got companies that have gone from being, you know, a few people in a small industrial unit to being a decent player in the UK supply chain, supplying now, you know, a relatively mature company, and they're growing. So that's one area. And the second area was, and it's linked to that, is industrialization capability. So what I mean by that is you've got this, you know, that person I mentioned before that's got a production line, and they know that there's something they need to do to improve how they do this bit of their production. What they need really is to go and have a go on a machine that's the top end at doing that. And so an example I'll give you is winding. So in Warwick, we have funded the Winding Centre of Excellence. So this has got various different bits of kit you might use to wind a machine. So in a motor, you've got, normally it's copper wound. And there's different ways of doing it, but one of the ways of doing it is to wind copper, and that makes your electromagnet. And there's every different motor will have a slightly different way of winding. And so Warwick have the know-how, so they've got top-end academics that know exactly what they're doing. Secondly, they've got kit, really, really expensive, very good, flexible equipment that people can go and say, this is my motor, I've designed it, it looks like this, I need to work out how to wind it. And then they can spend a bit of time working with the equipment and the expertise to then work out how they're going to manufacture that new motor. And then they can go back and either purchase the equipment they need or alter their equipment they've got to improve their production process for winding that motor. And that kind of equipment exists for various different elements of the power electronics, motors and drives community. So that's the industrialization capability. We've spent about £33 million on that equipment around the country. There already was 300 or so million pounds worth of equipment around the country already in various different academic institutions and catapults and other private enterprises around the country. What we did was sort of did an audit of that and spoke to industry and said, what is it that's missing from this? So this is what we've got. What's missing? And that's where we targeted the government funding. So we targeted very much at the bits that don't exist now, and they do now because we've opened them, and they're all opening. They have been opening over the last few months, and they'll be opening during the course of this year.
So let me create several scenarios for you and around these industrialization centres. So small business that you mentioned, they don't have the facilities to make anything in terms of manufacturing, and they've not got the budget to invest in the machinery. So they can go to the industrialization centres. Is that correct? Yeah. Yeah.
So they'll go to industrialization centres. They'll work out how they're going to make their new invention, and then they'll go back, and once they've worked it out, they can then speak to investors. They can go to a bank, whatever they need to go, and then to build that supply chain. Build that manufacturing process, because they know exactly what they're doing at that point. And then, there's a second example though that I should mention as well is the large companies. So there might be a company that already is producing, because we're using the example of motors again, and if they turn off their production facility, they're going to have annoyed clients that aren't getting the motors that they ordered. They're going to be losing millions of pounds, because if you turn off a production process, centre for a couple of hours, it's a big problem. So they can come to the Winding Centre of Excellence, and they can practice on how they're going to improve their process, or they're going to manufacture their new product without ever turning their production line off. And then once they've worked it all out, they can then go back and make the adjustments, and then boom, they're off again. Without
they can prototype there too. They can prototype.
Yeah, they can do prototyping there as well. Absolutely, and it will be used for prototyping as well.
So, how many of these industrialization centres do you have around the UK?
So, the community of industrialization, I guess, equipment and capability around the country, there's over 30 physical locations that you can go to, and then there's 4 leads that are humans that you can go and speak to about and they all cover slightly different areas. You can speak to any of them, and they will then pass you on to the most appropriate person. And those leads will then talk to you about what it is that you're manufacturing, and how best the industrialization centres as a whole can support you. Because it may be that, a bit of what you need might be in the South Wales cluster, a bit of what you need might be in Strathclyde, a bit of what you need might be in Warwick, and actually you need to work with all three. So the industrialization centres, innovation, the leads, they can support you and I guess help you with making sure you know the breadth and the depth of all the equipment that we've got and how best that might then be used to support you as an organisation.
You mentioned there were 3 pillars. What's the last one?
The third one, last but very much not least, is skills. So it's all well and good, funding a company so that they can go and they know how to manufacture their widget and they have their production line all ready to go. And then there's nobody there to actually bolt these components together. There's nobody there these are some incredibly highly skilled jobs. It's not just that anyone can do them. They need some serious training and skills to be able to manufacture these components. And the skills gap we've got in the UK globally, this is a problem across the globe. There are not enough people that know what they're doing when it comes to manufacturing the PEMD components that we need. And in the UK, it's certainly in the thousands. Some put it in the tens of thousands, high tens of thousands. The people that we need in a few years' time and now, and versus how many people are projected to be available. And what we've done is a few different things. So one thing we've got is the Electric Revolution Skills Hub. So this is a central location that anyone can go to, whether it's an individual or a company that are looking to retrain or reskill or upskill, or potentially they're leaving formal education and thinking, what is it I'm going to do next? What skills do I need? What course could I do to get in there? Or it's a company, a smaller company that's saying, I've got these 3 employees and I think I can probably upskill them and bring them into this bit new thing. Or it's a large company, whatever. They can enter that portal from one side. And then on the other side of the portal, you've got everyone who's providing the training. So whether that be a further education college or a university or a private provider, and there are some fantastic, all 3 of those in the UK. And they will then put their course on. And the key bit, the really important bit, is the lexicon behind all of that. So the language behind all of it. So you've got a company saying, I need someone that can do X, Y, and Z. And you've got the employee or the person that wants to move into that area. I therefore need to have a course that can do X, Y, and Z. And then you've got a course provider that's saying, my course does X, Y, and Z. And all 3 of those people know what X, Y, and Z mean and agree what X, Y, and Z mean, so that you've got then people coming out the other end of it who can turn up and on day one can do whatever it is that the company needs them to do. And this is all what I've just said is all industry focused, all industry led. So it's designed for and been designed with the industry so that it is usable and useful for them. It's going to be, it's launching imminently, and it's going to be a really fantastic resource. All in good having that great resource. What we don't still have enough of is the courses available, and that's another thing that we've been putting quite a lot of money into. So a bit more than £4 million has gone into various different courses around the country, and they're all focused on sort of industrial skills, what the industry need, the type of skills that are required, the type of knowledge that's needed, so that when people come out the other end of these courses, they're ready to be manufacturing these things or whatever it is.
Just for the sake of the people listening to this podcast, the Electric Revolution Skills Hub is also known as the ERS Hub. There is actually an interview with Deepak Farber that goes more in depth into the ERS Hub and what it's actually for in terms of businesses and individuals alike. So I'll put a link to that in the top corner so that if you want to watch that after this podcast, that you can do. It's definitely more focused on the ERS Hub. So Venn, the ERS Hub is for not only for individuals that are looking to upskill, but for businesses potentially to send their employees to. So it's a bit of both.
Absolutely. Yeah, absolutely. And what I've been talking about, those three things are so interlinked. So going back to the Winding Centre of Excellence that I mentioned, they've got that equipment. So not only are they working with industry on how to create their new way of winding something, they're also providing that availability when it's available for retraining and reskilling. So companies can send along people that have never wound before but are excellent engineers, and they can be taught on how to do it on a state-of-the-art piece of kit. So that's something that's happening. The Weld project is and that's that type of thing is happening around the country. And the Newcastle project we've got around skills is incredible. When you think about the breadth and depth of that, it is. So we put just shy of £1 million into it, but it's a £3 million project in total. The rest of it coming from other sources, including the university itself. And that looks at all the skills required for example, Nissan, a big employer around there, all the skills required at Nissan and other sort of electrification-based jobs in the Northeast. And then rather than having all the further education colleges providing their own course here, their own course there, it is all joined up. So each further education college is going to not specialize, but they're going to work on different skills required, so that as a person that's looking at what they might do next, they know exactly where to go, and it's kind of directed by and supported through the work we're doing through Newcastle there. So it's a kind of a new way of doing skills, and there's a number of different fantastic examples of the way things are happening around retraining and reskilling and different ways of thinking, because it is a step change that's required. It's not just doing the same thing we've been doing over the last decade again.
So the future is bright for electrification. Obviously, your guys' job is to try and meet that curve with everything else, with the skills and obviously the industrialization centres. Thank you for doing this with me today. I really appreciate that your time's quite precious in these big projects. Do you want to talk? Do you want to sort of leave anybody any links, or if anybody wants to find any further information about driving the electric revolution, where can they go? Where do they find out where they can get involved, whether they're businesses or individuals?
Absolutely. So obviously the ERS Hub is a good place to start if you're interested in getting into it. And as I said, it is, if you're interested in climate change and you want to do something practical about it, this is a really good place to start. If you're a company and you're interested in research and development funding, then the Innovate UK website's always up to date with the latest funding competition rounds. If you are interested in those industrialization centres, the Driving Electric Revolution industrialization centres have a website which we can share. It's going to be an interesting future for electrification, and I suppose it's happening globally at such a rate. Everything is electrifying, and the UK is going to get, based on the work we've done, the UK is going to get a good piece of that electrification pie.
Wonderful. Thank you very much, Venn. Thanks again, and take care and have a great rest of the week.
Thank you.